Hello friends, welcome you all in this lecture number 10.3. The title of this lecture is Laser Components and Lasing Action. I am Dr. Mohan Verma from Department of Applied Physics, Sri Shankaracharya Technical Campus, Juna Bhilai, and this is the part of CS02 Physics. Learn with me the special topics, lectures on some special topics. So the outlines, as usual, the objectives and prerequisite and requirement of laser action, pumping schemes, 3-level pumping schemes, 4-level pumping schemes, and these are the parts of this pumping scheme. Then optical resonator, that is also known as the Fabry Perot resonator, basic components of laser, and the summary. So objectives: to explore the lasing actions to obtain laser, and to explore the different components of laser. And the prerequisite for this lecture, expect from my student that they should have the basic knowledge of quantum theory of light, as well as some phenomena related to light, that is that interference. Now the requirement of lasing actions, we have also discussed in the last lectures. Then we have two basic requirements of lasing action. One is the numbers of atoms at higher energy level must be greater than the atoms at lower energy level, so N2 must be greater than N1. So the process of achieving a large numbers of atoms in the excited state than the ground state means this condition N2 must be greater than N1. This is known as population inversion, and this population inversion is actually achieved by using a process that is known as the pumping process. So we will discuss in this pumping process details in the next slide. And the second condition, that is the energy density of stimulated radiation must be large, and this max P21, that is stimulated transition, it is much greater than P12. So the stimulated emission exceeds the spontaneous emission, and this is only possible when we give extra energy, high energy values to different to atoms of the different energy levels. So by fulfilling these two conditions, we can get laser. And this second condition, that energy density should be high, it is fulfilled by using two different pumping techniques. These pumping techniques are actually the energy giving techniques. It depends on various types of laser. For example, for solid state laser, and we have the example of solid state laser, ruby laser, NdArc laser, these pumping techniques are used as flash tubes. For gaseous laser, just like carbon dioxide laser or helium neon laser, we use that electric arc method. And the semiconducting laser, where you use semiconductor, then the direct conversion of electrical energy is to laser. This pumping technique is used. So that ordinary laser which is used in PowerPoint presentation, that is that semiconducting type laser, where we generally use a simple battery. We just keep switch on and we get laser beam. So what's about the first condition, that N2 must be greater than N1? How it can be fulfilled? So during that laser mechanism, we discussed about two level systems, where we have this ground state, and where we have that higher energy level. So the atoms of this ground state excites up to higher energy level, and then come back to ground state by emitting that photons, either through a spontaneous process or through stimulated transition. But here I would like to mention here that by using these two-level system, that the first condition, that is N2 must be greater than N1, cannot be fulfilled. That population inversion cannot be fulfilled by using this only two-level system. And the reason is the time span delta T for which atom have to state at the higher energy level, this E2, it must be larger, but this is very small, that is only 10 to minus 8 second, and as in turn the total probability of spontaneous transition, this is equal to the total probability of absorption transition. So the population inversion condition by using these two level systems cannot be maintained using this two level system. So in order to enhance this lifetime at higher energy level from 10 to minus 8 second to higher values, we use this Heisenberg's uncertainty relation. Delta E multiplied by delta T, it is greater than are equivalent to h cross by 2. So if you want to enhance this delta t, see delta t is equivalent to h cross by delta e. So if we reduce that energy gap between these two levels, then the lifetime of atoms at higher energy level can be achieved, and this is not possible in two level system. Then we use some more energy level systems, and here that is the three level pumping scheme. So in this three level pumping scheme we have this ground state, and then we have this E2, and this is E3, that higher energy level. So from the ground state, by absorption transition, this atom is given to for the absorption transition, the atoms of ground state excite up so higher energy level, that is E3. Here its lifetime is obviously that is 10 to minus 8 seconds, and there is some probability of spontaneous transition also, and the maximum atoms are stimulated accumulated here in this A2, that is known as the meta-stable energy level, by a non-radiative transition. Non-radiative means there is no emission of photons here during the transition of atoms from this E2 to E3 to E2 level. So here these atoms are accumulated at E2, this meta-stable level. Now that energy gap in between that E1 and E3, it is reduced to E1 and E2. So as in turn the lifetime enhanced up to 10 to minus 4 to 10 to minus 3 seconds. So the population inversion condition means N2 is greater than N1, it condition is fulfilled in between. So when we give the external photon here to the atoms of this meta-stable level, this stimulated transition starts. This is the chain reaction, and through which we can get laser. So the deficiency of this three level system is its efficiency is very less, only 0.2% of the input energy is converted into laser. And second main deficiency is we get pulse from laser, because that population inversion condition is not continuously maintained in between these E1 and E2. In between it is failed several times, so we get pulse from laser. So these are two main drawbacks of this three level system. So the limitations of three level systems have been overcome using four level pumping schemes. Here in place of three levels we have four levels. This is the ground state E1, this is E2, this is E3, and this is E4. So E2 and E3, these are the meta-stable levels. So the atoms of ground state excite up to higher energy level through absorption transition, and this higher energy level is E4, where its lifetime is 10 to minus 4 seconds as usual. And there is one rapid decay, that is non-radiative transition from E4 to E3 takes place, and this is the non-radiative transition, and again the lifetime enhanced here because of reduction in the energy gap, and the population inversion condition is now maintained in between E3 and E2. So when we give that external photon here, stimulated transition starts, and this is the chain reaction through which we get laser. And here that population condition is maintained continuously because this is in between E2 and E3, and by a simultaneous process, by a spontaneous process, these atoms of E2 come back to this ground state, and by this cyclic process we continuously get laser. Its efficiency is slightly more than that three level system, and we get continuous laser, and that's why this is known as the better pumping scheme, which is used in gaseous laser, and that three level system is used in solid state laser. And the two levels in between we are getting laser, these are known as the lasing levels. So here that E2, it is lower lasing level, and this E3, that is the upper lasing level. In three level system, that E2 is upper lasing level, and E1 is E2 is upper lasing level, and E1 is lower lasing level. So this is a four level pumping scheme. So by using that three level systems and four level pumping schemes, that first condition, that N2 must be greater than N1 is fulfilled. Now, one of the important part of laser is that is the optical resonator, which is the Fabry Perot resonator, and this is the schematic diagram of the structure of that resonator, that is also known as a resonator cavity, Fabry Perot resonator. This is one transparent box containing that active medium and active center. So we will discuss what is that active medium and active centers in the next slide. And this is sandwiched between two mirrors. This is partial polished mirror and this is 100% polished mirror. I mean, this is 100% reflector. This is partial reflector, and we use that energy sources, that is the pumping process, pumping techniques here on this active medium. And that process of 3-level system and 4-level system is occurred in this inside this particular transparent box. So we can say that at the ground state, when we give energy, the atoms of excited state, atoms excites to higher energy levels by absorption transition, and that at metastable level, that atoms are accumulated through a non-radiative transition, and that population inversion condition is maintained in between that ground state and that metastable levels, and all these phenomena are inside this transparent box. So the basic mechanism of that optical resonator is given here using these 6 parallel figures. In this first figure, these are that active centers and active mediums are here inside that box, and this is that 100% reflected mirror. This is a partial reflected mirror. So by using that pumping techniques, the atoms are now excited now at excited energy levels, and all these photons are those photons which are coming out through that spontaneous process. So there is certain probability of a spontaneous process from higher energy level to ground state also, and these photons are coming out through that spontaneous process. So since this system is transparent, so along y and z direction, the photons are emitting that can go out from the system, and the photons which are moving along positive x-axis or along x-axis is confined inside this system. So let's see, these photons are now moving along positive x-axis, and other photons are coming out either along z-axis or y-axis now. So these photons are now going to positive x-axis. There is some probability of photons which are going outside of the this system along x-axis also, because this is partially polished. So the maximum, more than 90% of the photons moving along positive x-axis reflect back to negative x-axis using this partially polished mirror. And now these photons which are now moving along negative x-axis stimulate the atoms of metastable energy levels which are ready for that stimulated transition. So let's say if we have n numbers of photons moving along negative x-axis, stimulate n numbers of atoms and become double. So all these photons are moving along negative x-axis, and these photons come to this 100% polished mirror, and then again 100% photons will reflect back. So this type of oscillation inside this cavity, inside this resonator continuously take place, and after a certain numbers of oscillation we get this type of parallel photons, and all these parallel photons fulfilling that conditions for constructive interference converts into high intense beam, and now this mirror, that is partially polished mirror, is not able to block those photons, and which has been converted into a form of that strong beam that is known as laser. And this is that condition for forming a standing wave within that resonator. If all those photons fulfilling this condition remains inside this cavity, and other photons can go outside of this particular system, and these are standing waves by using that m is equivalent to 1 and m is equivalent to 2 and m is equivalent to 3. So this is the condition for standing waves. So this is the mechanism of optical resonator I have discussed, and then the component of laser. So we have now so in order to get laser practically, we must have it's the following components. First one is the active medium. These are actually the lasing materials. So it is the material in which the laser action take place. The active medium may be solid crystals, just like in ruby lasers and diag laser. Liquid dye are gases like materials, just like carbon dioxide or helium neon gases. Or semiconductor conductor materials, just gallium arsenide or gallium phosphoride. And this medium actually decide the wavelength of laser radiation also, and also works as host for active center. This absorbs extra energy released and also create the base for the laser. That's why this active medium is also known as the heart of laser. Second component of the laser is active center. Active medium contains atoms which can produce more stimulated emission than spontaneous emission. So active centers are those atoms which are taking part in different transitions. So the active centers are those atoms which are taking part in different transitions. And for example, in three type or four type of pumping systems, we have mentioned that out of N1 at the ground state atoms, N2 atoms are excited to higher energy level. So those N2 atoms which are taking parts in different transitions are known as active centers. So all atoms in active medium are not active centers. Only those atoms which are taking parts are active centers. Now energy sense sources. This is actually the pumping process, pumping techniques, energy giving techniques to pump atoms from ground state to higher energy level. And this by using this process, that second condition that you knew must have very higher values, it is fulfilled. So it depends on the type of laser. For solid state laser, we use flash tubes as a pumping process. Gaseous laser, electric arc method, and semiconducting laser, the direct conversion of electrical energy to laser is used as a pumping source. And the fabricate generator is also one of the crucial component of that laser. So if we want to fabricate a laser system, then we must have active medium, active centers, and a pumping process, as well as that fabricate resonator. Summary. In this lecture, following points were discussed in detail: conditions for obtaining laser, 3-level and 4-level systems, optical resonator and lasing actions, and various components of laser. So these components are will be used to fabricate laser. And different type of lasers will be discussed in next lecture. Thank you all.